Hello everyone and welcome to our group's project about artificial intelligence. And today's topic is about pathfinding in a maze. This project aims to utilize and implement AI within our daily life, games, and work. So here's our code base. There are three parts: the algorithms, the scenes, and the utilities, as well as the main function. And our language of choice is Python and by extension Pygame. And all of our code is hosted and controlled on GitHub. So let's begin. There are 5 options the user can choose. The most to generate a map, the different algorithms to select and run, the start button to start an algorithm, a way to reset a map like this, and a return button to the main menu. Now, once you select the map, you can see many different color of tiles. The cyan tile is the wall, the white tiles is the nodes. The number ones has its weight shown accordingly, and the one that doesn't have an automatic weight of 1. The start tile is green and the end tile is purple. Now, narrow maps are generated using Prim's algorithm, and room maps are generated using recursive deepening. And sometimes a room map doesn't generate, the room map and the randomized map doesn't always generate a path to a goal. So the user can choose any tiles and flip it, a wall to a node to a node to a wall, while also retaining its cost. And once any algorithm is selected and started, its statistics are shown as here. And when it's finished the path will be highlighted in yellow, and the total path cost will also be shown. Once you select another algorithm, the previous algorithm statistics is also shown over here, so you can do comparisons. Once you select a new map though, it doesn't show anymore. Now let's go over each function, each algorithm independently. We will start with DFS, depth first search. Like it says, it always searches each singular path first before, if it doesn't find one, it switches to another one. And in reverse to its function, we have breadth first search. BFS. It searches all paths simultaneously and it stops the goal. Breadth first search is better on maps where each relative path length is low, and depth first search is better on map where like a narrow map like this, where a goal can be found most likely on one singular path. Those two we will explore all uninformed search first. So the next one would be iterative deepening depth first search. It's almost the same as DFS, but it has a threshold, so it stops DFS from exploring a path too far. Once you explore everything, it resets, increases the threshold, and repeat. This stops DFS from exploring a path too much and ensure that you can slowly reach the goal, though the runtime may be a lot bigger and the visitor knows as well. Bidirectional search is not necessarily any type search, just a way to search. So this one is combined with BFS, and the thing it does is it tracks from both the start and the goal. And the good thing about bidirectional search, like a version like combined with BFS or USCS, is that if every single node has a uniform weight or cost, BDS will always find the best optimal path, because the optimal path will be reached first on the set of the starting node and the set of the end node. And then we have to the informed search, starting with beam search. Now beam search uses a concept called beamwidth and works similar to breadth search, but not exactly. I will demonstrate. like this. So beam search is the end. Let's say that beam width is 2. It will only explore 2 nodes at a time. It will not explore L because it utilizes and prioritizes the path with the lowest cost. So we got F here, and then I. It will only explore 2 at a time. It explores the same amount of nodes at the beams as the beam width that you started with, and then in our case it is 3. I'm sorry, it is 5. And the thing about beam search is that it doesn't necessarily always find a path to the goal, even though there is a clear path for one, like this case right here. Because one, it has, for the special case in route map, it can generate a map that can be misleading to the beam search. And once it has exhausted all of its path, it doesn't store any other nodes, so it stops and can explore further. In this case, it did not find gold even though there's a clear path here. Next is uniform cost search. Also behaves like BFS, but let me retry. Instead of behaving like BFS, it stores the number of. It uses a priority queue to store the objectively best path to each node. It keeps exploring like that. So in this case, we store F as 51 instead of 43 plus 29. It will always store the best cost of each node as it keeps exploring. It selects the lowest one at each iteration. And it will always find the best path if all weights are positive or 0. A star also uses a type priority queue and uses a term called heuristic. Now a heuristic is a way to estimate. Let me just demonstrate. It fast right here. And the heuristic is a way to estimate the actual cost of a certain node away from the goal. Ideally, it should be admissible, which means that it should always be lower than the actual cost of the path. And in our case, it is simply the distance from the node to the goal. And if it is the case, then A star will use the total cost as F equals C to H. So in this case, like 43, this one is 4 away from the goal, 43 was 4, 53 was 4, 66 was 4, and we'll explore this path first. It will keep doing this till it finds the goal, and it will always find the best path in the case where the heuristic is admissible. That is the first step. It will continue to go. This because it's 47, which is lower than the combined cost of this, which is somewhere above 50. It will continue to doing this till it finds the goal, like this here. Now, iterative deepening A star is very much the same as A star, but it uses a stack to store its memory. So it can't be as fast. It is much slower, in fact. It resets each time, upping the threshold each time. But it uses linear memory, and it updates using its currently best visited cost on each iteration and use it on the next iteration. And so it retains linear memory, finds the best path if the heuristic is admissible. And that is one advantage it has over A star, that is the memory. The memory is only linear. And so this is the end of our showcase. Thank you for watching and have a great day.